Year 7s, I hope you guys are doing well. I thought I would come to you today from the great outdoors just to talk with you again about forces. So if we think back, in week 1 we introduced forces. In week 2 we looked at friction and we said friction is a contact force and it works in the opposite direction of the way something is moving. Last week we spoke about a non-contact force, and that was gravity. We talked about the difference between mass and weight. We said that mass is the amount of matter that an object has, whereas weight, that's actually a force. So we measure it in newtons, and it is the amount of gravitational pull on an object. We spoke about what is gravity and came to the conclusion that, well, any object that has a mass has its own gravity. That's why we are drawn to the center of the earth. That's why we're not floating up into space, because the earth has such a large mass that it has a really large gravitational pull as well. And in fact, the further you were to get away from the earth, the less that gravitational pull would have an effect. The moon, we said, has a smaller mass, so that's why it has less of a gravitational pull on objects on the moon. That's why astronauts can kind of bounce along, right? But we can't do that here on Earth because the greater mass means the greater gravity. Today, we're going to speak about another form of non-contact force. 2 types, actually. The first being magnetic. So, if we think about the region in which a magnet has an effect, that's called a magnetic field. Maybe you've heard of that before. As far as magnets go, let me see. Here they are, found them. We know that a magnet has 2 poles, right? It's got a north and a south pole. We know that like poles, so north and north, they repel each other. But unlike poles, so north and south, they actually attract each other. When I say north and south pole, what do you think of? Probably the north and south pole of the earth, right? And although the earth doesn't have a big magnet in the center of it, it does still have its own gravitational field surrounding it and within it. And the reason for that, scientists believe, is due to the iron core, the hot, molten, melted rock core at the center of the earth. They believe generates this magnetic field that we can utilize by using a compass and seeing, oh, okay, it's this direction, is not. Even birds and some fish and other animals use the magnetic field to help them travel on their journey. What I love most about the magnetic field of Earth, though, is that beautiful, dazzling light display that you can see in the north and the south poles. It's actually one of my to-do travel destinations, to go visit Iceland or Norway to see the northern lights. You can also experience them down south as well. That is because of the magnetic field. So if you think about the sun emits light energy, but it also emits what's called solar flares or solar wind, and that's like this big burst of energy, this light energy. And sometimes when those big flares come down to Earth, our Earth's atmosphere blocks them, which is good because it's really damaging to living things otherwise. And the Earth's magnetic field actually channels those highly energized particles to the poles, to the North Pole and to the South Pole of the Earth. And when those highly energized particles from the sun crash into each other at the poles, it creates that stunning light display known as the aurora. So that is a magnetic field. It's, you know, we could go deeper and talk about what actually creates this like magnetic force within magnets or within metals. And scientists believe that within something magnetic, there's actually all these mini little magnets within inside it. And you'll read this in your textbook. And all those mini magnets line up, so all the north ends are facing this way and all the south ends are facing this way. Well, it means that that particular type of object is actually magnetic. But if those little magnets inside aren't facing all in the same direction, if they're just random, well, that particular metal is non-magnetic. So super interesting, right? As far as electric fields go, this is another non-contact force that we experience very often as well. Have you ever been walking on carpet and you've touched a door handle and you get that that zap? Or thought about, why does lightning occur? How does that even happen in the sky? Well, that's all because of electric fields. To talk about an electric field, we have to talk about the atom. So maybe in science you have never heard of that word before, atom, but every object, whether that's your computer, whether that's the rocks on the ground, or the chairs or the desks that we sit at, every object is actually made up of atoms. And within, so they're so small, they're microscopically small. But within an atom, there's even smaller little particles. And there's 3 that we're going to talk about. So check out your textbook in 7.4, and there's a diagram to make sense of this. But an atom is made up of 3 parts. We have protons, and protons, like the name suggests, begins with P. They actually have a charge, and it's a positive charge. Neutrons, as the name sounds like, have a neutral charge. That means they don't have a charge at all. But also in atoms there are electrons, and electrons have a negative charge. So electric fields work using these different charges within atoms. Let me give you an example of static electricity. When you are walking on carpet and there's friction between the carpet and your foot actually gathers up those electrons from the carpet. And remember, what charge do electrons have? They have a negative charge. So as you walk and you're building friction and that negative charge up as your feet contacts the carpet, you become negatively charged. And remember, with our magnets, opposite charges attract each other. So if you are negatively charged with all those electrons that you just picked up from the carpet, and you go to touch something that doesn't have a negative charge, like a door handle, then there's going to be a big release as those electrons jump to that opposite force, and that comes out in the form of a zap. And that's why you can get that little electrocution shock from walking on carpet and touching a door handle. Door handles, the reason why being the object that we can often feel that zap on, is because it's a metal, and metals are good conductors of electricity, so they receive that really quickly. And that's a bit of a crash course on magnetic fields. So we talked about north and south poles, how like poles repel but opposite poles attract. We spoke about how the Earth has its own magnetic field. That's how we use compasses and why we get the great northern lights. And then we spoke briefly about electrical fields and how static electricity is an example of an electric field. And we spoke about the atom, how the atom is made up of protons, positive charge, neutrons, neutral charge, and electrons, a negative charge. And when there is an imbalance between charges, then often there's this big zoom that happens, like when you're walking on carpet and you touch a door handle. So, bit of a crash course, hey, but guys, I hope that you learned at least one thing from this video and that you enjoyed it nonetheless. Let's have a quiz after this and see what you guys took away from it. So, God bless you, and I will be seeing you back in the classroom, I'm sure, very soon.